This formula works for all integer values of n, so the proof will be conducted in two parts. The first will be the proof by mathematical induction for all natural numbers. The second part will be a direct proof by using the previously proved statement. Part 1, Pn says z to the n equals r to the n cis n theta for all natural numbers n. The first step of mathematical induction is the base. Since the statement is true for all natural numbers, you must apply the formula for n equal to 0. n equals 0 implies p0, which is z to the 0 equals r to the 0 cis 0 multiplied by theta. Rewrite the polar form in Cartesian form and use the values of sine of 0 and cosine of 0. Implies 1 equals 1 multiplied by cosine 0 plus I sine 0 implies 1 equals 1. The statement is true. Therefore, the formula works for n is equal to 0. The next step of mathematical induction is the assumption. You need to assume that the formula works for a certain natural number called k. n equals k implies pk, which is z to the k, equals r to the k multiplied by cis k theta. The third step of mathematical induction is called the inductive step. You need to see whether the formula works for the next natural number, k plus 1. n equals k plus 1 implies p k plus 1. z to the k plus 1 equals z to the k multiplied by z. In order to prove the inductive step, you need to use the assumption. Use the rule for multiplication of two complex numbers in polar form. r to the k cis k theta multiplied by r cis theta equals r to the k multiplied by r cis k theta plus theta. Simplify the expressions and notice that the obtained result is the formula for n equals k plus 1. Equals r to the k plus 1 cis k plus 1 theta. The last step of mathematical induction is the conclusion. Since p0 is true and pk implies pk plus 1, by the principle of mathematical induction, Pn is true for all natural numbers n. The second part of the proof will be a direct proof using the previously proved statement by mathematical induction. Part 2. The statement that remains to be proved is for negative integers. Z to the n equals r to the n cis n theta for all negative integers n. Every negative integer can be written as a product of a negative 1 and a positive integer. n equals negative 1 multiplied by m, where m is a positive integer. Use the power property of the inverse of complex number. Z to the n equals z to the minus 1 multiplied by m equals 1 divided by z to the m equals 1 divided by r multiplied by cis negative theta to the m. Use the power property of complex number in the polar form and simplify the expression. Equals 1 divided by r to the m multiplied by cis m multiplied by negative theta equals r to the negative m multiplied by cis negative m theta. Rewrite the answer in terms of n. Equals r to the n multiplied by cis n theta, where n is a negative integer. This concludes the proof of the original statement that the formula works for all integer values.